So hello everyone, today we will learn about AdaBoost classifier, which means adaptive classifier. So what does it mean? So this is boosting algorithm, which means to get more specific result or more accurate result, we use this. So today in this lecture we will learn about how to solve AdaBoost problems, and let's start with this. So let's see the steps first. Okay, like suppose you have a root node. So from there you are trying to apply adaptive classifier. So suppose there is two class, which is one true and one false, and here you can see the majority of the results are true and one false, and there you can see the majority of results are false and one true. So here we will decide which is the majority result. So we will take the majority as normal result, and the other one is misclassified. So here you can see there is 3 true and 1 false. So you can take decision that the result must be true, but there is one misclassified data. So you have to determine misclassified data this way. Like here is one misclassified data. Okay, then what happens here? Here is 3 false and 1 true. So 3 is greater than 1, so the supposed result is false but 1 true. So the misclassified data is true, and the quantity of is 1. So this is how we determine the misclassified data. So overall we can say that we will take the majority result as a decision. Here we will take majority result as decision. Okay. Then the first step is to find the misclassified data, and then the second step is to find the total error. So how do you find total error? So here will be the summation of misclassified data. Okay. Then we have to find out the amount of say, which we call alpha, as equals to half to 1 minus error divided by error. Total error we define it by epsilon. and then we update weight using this value. There are two different formulas, like for incorrectly classified, we use sample weight into e to the power alpha. That means sample. So what does it mean by sample weight? Sample weight means 1 divided by total number of rows. So for incorrectly classified data, we use this formula, and for correctly classified data, we use sample weight into e to the power minus alpha. So basically here you can see we are giving more importance to the incorrectly classified data to purify it in the further iterations. Then we have to update the table. Then there is normalized, then cumulative normalize, sample weight. So let's see this in an example. So basically the steps are, firstly we have to determine the misclassified data, then we have to find out the total error, and then amount of set, then update weight, and then we have to update the table, and so on. For better understanding, let's have a look into an example. Like here you can see there is 14 examples, right? Here you can see here is 14 examples. So here the sample weight is 1 divided by 14. So then we have to find the root node, which will be the root node using gain impurity. So as we know the gain impurity, we are not repeating this here. So then we will find the gain impurity. Then we will find the root node. Then the same way we will find the error, then amount of say, and then we will update the table. So let's see this problem solved in a PDF that is given by our teachers. So basically that problem was from here. So this is the problem, and here you can see that the sample weight is like 1 divided by n, and then they found out the Gini impurity and took the lowest one, like for sunny, outlook for sunny, overcast, rain. Then they found out the Gini impurity of outlook. Then the same way they found out the Gini impurity of temperature and then humidity. Then they took the lowest Gini impurity as root node. So they found out that the outlook is the root node. So here is the main point, that here you have to take decision. Like in sunny, there is 2 yes and 3 no. Two yes and 3 no. Okay, let me fix it. So the majority of decision is no. So there should be the answer is no, but there is 2 yes. So the misclassified data is 2. Then do the same for it for rain. Here is 3 yes and 2 no. So the majority answer is yes. So the expected result is yes, but there is 2 no. So the misclassified data is 2. So the same way we will find out for overcast. Here you can see there is 3 yes and 2 no's. So the expected result is yes, but we get 2 no. So the misclassified data is 2. So then we have to find out the total error. So we got we have got sunny, rain, overcast. Basically here will be the 0. Here will be 0. So my bad. Here is no misclassified data. As you can see that there is 4 yes and no no. So here you can see there is no misclassified data, so 0. So we have to find out the total error from here. So total error will be 2 into 1 divided by 14 plus 2 into 1 divided by 14. So what will be the answer? Let's see here. Here you can see 2 into 1 divided by 40, 2 into 1 divided by 40. So why 2 into 1 divided by 40? So basically we found the sample weight for each of the samples 1 divided by 14. So 2 misclassified data. So we multiplied it by 2, and the same way we found out error for rain. And this way we found out the error. Then we can easily keep the value here and find the amount of say. Okay. Then we will update correctly classified data and incorrectly classified data. In incorrectly classified data, we are using the amount of say without negative sign so that this value gets bigger. So sample weight into e to the power alpha, And for this correctly classified data, we try to reduce its significance. So we multiply sample weight into e to the power minus alpha, and we get this value. Okay, then we will update the sample weight into the table. So sample weight for correctly classified data, this. So how can we find this out? So for that, for Outlook Sunny, misclassified is yes. Okay, let's find out the yes values. Outlook Sunny, yes. Where is yes? There's yes. There is a yes. Here is misclassified data. We have to mark down the misclassified data for better understanding. And we got two misclassified data from rain, right? So the misclassified data from rain is the decision of no. So rain and no. Rain and no. Rain. There is no. Rain. Rain. No. Okay. So the misclassified value will be updated in these places. So let's see. Is it true or not? So here you can see the day 6 is misclassified data. Here you can see day 6 misclassified data. Then day 10, sorry, day 9, day 11, and 14. Day 9, day 11, and 14. So here you can see we have updated the misclassified value on the decision of misclassified data. And we updated the value. So we got the result of correctly classified data from using alpha, that 0.46, 0.046, right? Here it is. And for incorrectly classified data, we got 0.11. So this way we will update it here, and then we will find out the normalized sample weight. So for normalized sample weight, what we have to do? We have to do all the summation of this row and divide it by the summation, like 0.046 divided by summation of the whole column. Then this way we find out this result. That means sample weight, like you have sample weight 0.046. So then you have to do the summation of the whole column, then divide it through by the summation. Then you will find out the normalized simple weight. And this way, for calculating cumulative normalized sample weight, you have to do the add cumulatively, like 0.051, then 0.051 plus 0.051, then that gets 0.102, then 0.102 plus 0.051, then you get 0.053, then 0.053 plus 0.051, then you get 0.023, 0.204, then this adds with this, then this, this way you can get cumulative sample weight. Here's the example. Here's the formula. So here you can see they have kept the cumulative normalized sample weight only. Then they created generate random number. How did they create a generate random number? For this, they have kept the for correctly classified data, the distance is so small. But for incorrectly classified data, the distance is high. The distance is large. Distance is large. You can take any random numbers here as computer does it, so it can generate random numbers in no time. So you can assume this like if you have a correctly classified data, then you will take the generate random data nearly to your value, and if you have incorrectly classified data, then you can keep a distance. Like here you can see there is 0.100 something distance, and there is minimum 0.3 distance. This way you can create random number. So in the last part, if you want to go further simplification, then you will see creating new data set with random sampling. So here we will give prioritize to the misclassified value so that they focus on it to correct it. So we have taken this few data from the previous table, then we kept the misclassified data, then we kept one of the misclassified data. So here you can see here is 14 samples as it was before, but we have given priority to the misclassified data. And then you can see the new dataset. Then you can again use your AdaBoost classifier and less your error of finding. So basically, we can use AdaBoost for both classification and regression problem. So that's all. Thank you.